So in this video, I'm going to take the antiderivative of 7 over the square root of 4 minus x squared. And again, I'm going to use trig substitution because u substitution clearly wouldn't give me anything I could really work with here. So I look at the pattern of what I've got, and it's a number minus x squared in this case. And that number is 4, right, which is 2 squared. So when I have a number squared minus x squared, the pattern that I want is this one. So I'm going to let x be 2, because that's the a here, sine theta. And then we're going to go ahead and follow the process of normal substitution. You find the differential by taking the derivative, and then multiplying both sides by that bottom differential. And then we're going to do the substitution. So when I plug this into the integral, it'll be 7 times dx, which is 2 cosine theta, d theta, over the square root of 4 minus 2 sine theta squared would be 4 sine squared theta. Now, the reason we choose this a2 here is because we want the coefficients here and here to be the same, because that's the only way that Pythagorean identities actually work to simplify down to one term. So the fact that there's a 4 here and a 4 here means I can replace that 4 minus 4 sine squared theta with 4 cosine squared theta. Like that. So now I'm going to simplify this. The square root of 4 cosine squared theta is 2 cosine theta. And then this fraction simplifies down into just 7. So since I'm taking the antiderivative of 7 with respect to theta, that antiderivative would be 7 theta plus c. So now I just need to get this into x instead of theta. And that is actually a pretty simple process. When I draw the triangle that represents this, I would need to get the theta by itself first. So that would be x over 2 equals sine theta. And then theta is inverse sine of x over 2. Now in this case, normally I would draw the triangle and evaluate the trig functions that I need, but all I have here is a theta. So I don't really need to find any of those trig functions. I can simply say that theta is the inverse sine of x over 2, and I'm done. That's the antiderivative